Hello. Thank you for taking your time on our sessions. How to build a smart Raspberry Pi bot with Cloud Vision and Speech API. I'm Kaz Sato. I'm a developer advocate for Google Cloud Platform. And
I'm Glenn Shires. I'm a software engineer on the Cloud Speech API.
OK, I'd like to show us a demonstration video of the Cloud Vision bot at first. So let me share the video.
Cloud Vision provides powerful image analytics capabilities as easy-to-use APIs. It enables application developers to build the next generation of applications that can see and understand the content within the images. The service is built on powerful computer vision models that power several different Google services. The service enables developers to detect a broad set of entities within an image, from everyday objects to faces and product logos. The service is so easy to use. As one example of the use cases, you can have any Raspberry Pi robot like GoPiGo calling the Cloud Vision API directly. So the bot can send the images taken by its camera to the cloud and can get the analysis result in real time. It detects faces in the image along with the associated emotions. The Cloud Vision API is also able to detect entities within the image. Now, let's see how facial detection works. Cloud Vision detects faces on the picture and returns the positions of eyes, nose, and mouth. So, you can program the bot to follow the face. It also detects emotions such as joy, anger, surprise, and sorrow. So the bot can move towards smiley faces or avoid anger or surprised face. One of the very interesting features of Cloud Vision API is the entity detection. That means it detects any object you like. Let's see how it works.
It's glasses. It's banana. It's automobile. It's money.
You see? Cloud Vision lets developers to take advantage of Google's latest machine learning technologies quite easily. Please go to cloud.google.com/vision to learn more.
So that was the demonstration video for Cloud Vision bot. So I'd like to discuss how to build this bot by using the Vision API in these sessions. But I'd like to start briefly discussing about the machine intelligence working behind the bot.
Okay.
Thank you. So we are using technology called neural networks. So what is neural network? Neural network is a function that can learn from the training data set. So it's designed to mimic the behavior of neurons inside human brain by using the matrix operations. For example, if you want to do the image recognitions with neural networks, then you can convert your input image, such as the cat images, into a large vector, and then put that vector to the neural networks, where it does the massive amount of the matrix operations, such as the multiplications or additions between vectors and matrices. And then eventually you would have another large vector as an output, which represents the labels of the objects detected in an image, such as the cat or automobile or the human face. So let's take a look at another example how neural network works by using the dataset called double spiral. In this double spiral dataset, we have two groups of the data points. One is the orange group, then another is blue group. If you are a programmer and if you are asked to classify those data points, what kind of the program code you would write? Do you want to write many if statements or switch statements to, to classify the points, each location of the points by using the condition and the thresholds? Do you want to write that? I don't want to write that kind of code. Instead, I would be using machine learning or neural networks so that I can let the computer try to find a way to solve this problem. So let's take a look at the demonstration. This is a demonstration called Playground. where you can just actually running the neural networks to solve these problems. Now you are seeing the computer is trying to find the optimal combination of the parameters inside neural networks to solve this problem. Actually, it's not working right, so let's try it again. Yeah, sometimes the machine learning fails, so you have to try so multiple times. Now, here you go. The computer found a way to combine the parameters in an optimal way to do the classification with the double spiral data sets. So this is how neural networks works to solve your problem, rather than instructing the computers how to solve the problem by humans. Okay, go back to the slide. And you can apply these neural network technologies to solve the much more complex problems, such as recognizing a cat in an image or recognizing pedestrians walking around the street. You can do that, but you have to have many more hidden layers, the layers inside the input vector and output vector. So it takes so long time to finish training. That is called deep neural networks or deep learnings. But the largest problems right now for deep neural networks is the computation resource. It usually takes like a few days or a few weeks sometimes to finish your trainings with deep neural network. So that's the reason why Google has been researching on distributed training by using the Google Cloud, by using the GPUs or TPUs that can shorten the training times in order of 1/10 or 1/100th. And that is the reason why Google has been so successful on applying the deep neural network technologies to the many consumer services, such as the voice recognitions with Android devices, or the image recognitions with Google Photos, or the ranking in the Google search services. Now we have over 20 production services at Google that has been using the deep learning technologies underlying. And now we have started to externalize the power of the neural networks running on Google Cloud to external developers. The first product is called Cloud Vision API, and the second product is called Cloud Speech API. What is Cloud Vision API? Cloud Vision API is an image analysis service that provides the pre-trained model, so you don't have to train your own neural networks or machine learning model. Rather than that, you can just use the REST API, just sending your own images uploaded to the API. Then you will be receiving the analysis result in a JSON format in a few seconds. So you don't have to have any machine learning skill set or experience. And it's so inexpensive. It only costs $2.50 per 1,000 units or images, and it takes no charge to start trying out the API. So let's look at another demonstration for Cloud Vision API. Here I'm launching a demonstration called Cloud Vision Explorer, where we have imported over 80,000 images from Wikimedia Commons, uploaded on the Google Cloud storage, and applied the Vision API analysis already. And by using the result of the Vision API, we have done clustering analysis so that you are seeing the cluster of the images, such as sea cluster, or snow cluster, or estate or residential area cluster. And if you take a look at the cluster for cats, then you'll be seeing the many images that is classified as a cat, like this. If you put these images to the API will be sending back the results such as the cat or pet, or this must be a British short hair. All those results will be returned in a JSON format like this. But in these demonstrations, you can see them in the graphical UI. Also, if your image has a text inside it, then the API can convert the text inside the image to a string, like this. The 3 kangaroos crossing next 2 kilometers, you can get it as a string. Or if you have the faces in your images, then the API can detect the faces and locations of each face, and also the emotions of each face, such as joy or sorrow, anger, or surprise. So you can easily find which face is smiling or not. If your image contains the very popular locations, then it can provide the name of the popular locations, such as Citi Field Stadium in New York City, with longitude and latitude. You can even put the markers on the Google Maps. Oh, sorry. You can even use the product logo detection features so that you can easily understand the image has the product logo or corporate logo. So that was the demonstrations of the Vision API. So let's take a look at how you can bring this machine intelligence into the Raspberry Pi bot. So Cloud Vision Bot is based on a Raspberry Pi robot called GoPiGo, which is produced by Dexter Industries. So you can go to the Dexter's website to buy GoPiGo at around $200. And also you may want to buy a fisheye camera to capture the wider range of views surrounding the bot. And we have written a few hundreds of lines of Python code to capture the image by camera and send the image to the API. It's really easy to start getting started with the Vision API. You can just go to cloud.google.com/vision to getting started. You can try the quick start tutorial, and that should be finished within 30 minutes. This is a sample Python code to send your image data to the API. You have to convert the image binaries into the base64 text and embed that text into the content property of the request. And also you have to specify the types of the features you want to detect. In this case, it's specified the label detections as the features, so that you'll be receiving the labels as a result of the API analysis. And you can make the call to the API, then you'll be receiving the result JSON in a few seconds, so that you can easily dig into the JSON result to getting out the labels. If you specify face detection, then you'll be receiving the positions of the face and the landmarks, such as the bounding polyproperties, where you would have the X and Y positions. And also you will have the joy likelihood property, where you can find each face is smiling or not. So it's really easy to write a Python code to turn the bot into the direction of the face. And also, if it's smiling, then you can run the motors of the bot to follow the person. So let's take a look at the real demonstration of the Vision API bot. So I'm showing the console. So this is a user interface web console for the bot. So actually, it's showing the Vision it is taking right now. Not sure it's working or not. Must be working. I hope it's working. Is it working? Sure, let me try. So if you put the flowers, it's not saying anything. So it looks like it's not working anymore. Maybe I can try fixing this stuff, so while doing that, maybe I can pass the stage to him.
Okay.
Yeah.
So you want me to jump into my slides?
Yeah.
Okay. Yeah, hi. So I'd also like to talk about the Cloud Speech API, which is actually a rather new API. It was released about a month and a half ago. And it joins a number of speech APIs that Google has had for quite some time, quite a number of years. You're probably familiar with the Android Speech API, which allows you to do speech to text and text to speech on Android devices, phones, tablets, autos, TV, etc. So that's in Java. That's a Java-based API. There's also the Web Speech API, which is in Chrome, which is a JavaScript-based API that allows you to do speech. And the Cloud Speech API is a new API that we've released that allows you to put this on any device. So whatever device or server you'd like to put speech into, we've made it very easy, and we support quite a number of languages. So we've made it very easy to integrate this into all sorts of different clients and servers. The Cloud Speech API is powered by Google's machine learning. So we've got a lot of experience with speech, and we've built that all into the API. So it's the same powerful engine that you have on Android, you have on Chrome, you now have available for whatever project you'd like to use it on. The models are pre-trained, so there's you do not have to learn machine learning to specifically use it. You can just get up and running immediately. And it supports over 80 languages and variants of languages. It's got real-time streaming. And so what real-time streaming means is that as I'm talking, the text is actually coming out while I'm talking. And what I'd like to do is give you a quick demo of that. So I'm sure you're familiar with this page, which has speech on it, Google search page, Web Speech API. What I'm doing here is pulling up a demonstration page for the Chrome Web Speech API. And make it a little bit bigger here. So what I'm going to do is, as I'm talking, I want you to notice that the words are coming out. And they're actually, first they'll be gray words because it's not quite sure. And then when it's very confident of the words, it turns them to black. So you can see as I'm speaking, the words are coming out and appearing on the screen. They turn black after it's very confident of what I said. And where's the presentation? Okay. So that's an example of the real-time streaming that's built in. And we have a limited preview right now for which you can sign up and join and start using the Cloud Speech API. Cloud Speech API is actually two different APIs. There are at least two versions of the same API is probably a better way to put it. There's a REST API that's a very, very simple way to use it. You can get started immediately. It's as simple as writing a curl command and some JSON. And then there's remote procedure calls, which gives you more power. Let me show you the REST API. And this is literally everything you need to know to do the REST API on one slide. You see on the left, there's a JSON request. And you can formulate that. You can make it more complicated if you want, add languages, add different types of ways you want to process it. You can even add context. A new thing we released is the fact that you can add new words to the vocabulary and new phrases. And so that's coming out this week. So you can make it as complicated as you want, but the simplest request would be exactly that, those couple lines of JSON with the content where you insert your audio file or your audio data. If you look at the bottom, there's a curl command. Kind of long, but basically all it's posting is a content type and posting to a URL. So it's taking that JSON, posting the URL, and what you get back is that response that's on your right. And again, this is the simplest type of response. If all you want is one alternative, you don't want to see multiple alternatives and interim results, you'll get something that looks just like this. So as I said, there's actually two types of APIs. The other one is the remote procedure call API. And what that means is you can do everything by simply calling methods in your favorite language, in either Java or C++ or the 10 different languages that are supported. So you don't have to worry about the network. And it also supports the bidirectional streaming that I mentioned, so that as you're talking, you're getting the data back. So yeah, we support quite a number of languages for the remote procedure call. And this is actually open source. It's free and open source. So if there's a language that doesn't appear here, you can certainly build the source for that language and you actually use it on any language. It also uses HTTPS/2, which HTTP2 secure, which allows you to have some very robust bidirectional streaming. So what I'd like to do is demonstrate this. Go straight. Go straight. Go back. Stand still. Thank you. I like that command. Sit. Go to sleep. So I'm going to start that over, and we'll see. Let me move forward. So let me show you, while we're waiting for that to reboot, exactly what we're sending with the RPC calls. We're sending initial requests. Now, this is similar to the JSON that I showed in the last slide, but in here, we're actually using protobuffers to send this. So it's a very compact format. In other words, you're not sending extra bytes over the wire the way you are with JSON. So you send your request, you capture audio from the microphone, and in this case what we're doing is on a thread, we're reading a buffer full of audio and sending that buffer of audio. You will see what we're calling here is on next. So this request observer on next is code that's automatically supplied in any of 10 languages so that you can keep passing new buffers to it. And finally, you've got the response, which you can be running on a different thread because you're sending audio and receiving data at the same time. And again, there's an onNext command here that's provided automatically for you, which provides the data. And in this case, we're printing out the results of what we're receiving. Go forward. Spin left. Spin right. Go backwards. Do a dance. Go to sleep. Play dead. I like that one too. So there we are. So one thing I wanted to point out is it's responding very quickly, and that's because it's streaming the speech as I'm speaking. So it's not going to capture all the speech and then wait and then send a big chunk of data up. And as I'm speaking, it's going bidirectional, and so that's why I can do it so quickly. And my clicker is here. So what I'd like to do is, this is easier to show than to talk about, so let me show this. These are experimental features, I want to say. What I've showed you to date is what's available right now on the Cloud Speech API. These are experimental features that will be available soon. What time is it in Tokyo?
The time in Tokyo, Japan is 9:29 a.m.
How do you say, when is the next train in French?
Quand part le prochain train?
Turn on the table lamp.
Not sure how to help with turn on the table lamp.
There we go. Go to sleep. So as you can see, I've demonstrated two different things in that demo. The first one is spoken answers. And what that's doing is as I'm asking questions, it's providing answers. And the second one is something that we've actually integrated with if this, then that, which is a way that you can integrate with all sorts of different devices. In this case, I've integrated with a light module controller so that you can actually set up your own triggers to do this. And this is exactly what I did. There's a web page that I went to, and I typed in what I wanted to say as triggers, voice triggers, various ways I wanted to say it, and what it's going to respond when I do say that. And what it does is it goes out and configures this, and now when I speak that phrase, or one of those phrases, it goes out and triggers whatever if action you would like to trigger. So you want to go back to yours?
Yeah, let me try the. I'm not sure if it's working or not. Maybe I can show the console. Yeah, let me try again with the bot. Oh, looks like it's working. Yeah, it looks like it's working.
It's reduced.
Yeah.
It's light. It's currency. I'm
Currency.
smiling.
Yes.
How are you?
I'm fine. Thank you.
It's black hair. It's pet.
Yes, it is.
It's goggles. Hello.
Not goggles.
It's bag. It's eyewear.
Yeah, it's eyewear. How about this? How about this? Yeah, if you keep smiling, then it tries to follows me. What is this? Can you see this? Oh. Ah! Thank you. So yeah, it works finally. So that,
Passport.
yeah, thank you. So that was our demonstration.
Okay, shall we go back?
Yeah.
Okay. One thing I failed to mention with the if triggers, you can actually add parameters to those triggers. So you could add a number or a string parameter, and you could, for example, tell the robot to turn left a certain number of steps or degrees. So you can make the triggers actually quite interesting. So we have a number of resources that you should go out and take a look at. The Cloud Vision API and the Cloud Speech API. You are ready for sign up. And we also have, well, first of all, thank you, but we also have a number of other sessions that are coming up that you might be interested in. We have code labs that talk about machine learning. There's several machine learning presentations coming up. There's cloud office hours if you want to learn more about cloud and integrating with the cloud APIs. We have office hours throughout the next few days. And there's the sandbox. So thank you very much.
Thank you.